Okay, here we are. Calculus Chapter 4 Practice Test Part 1. Doing the key live and online. Alright, this is hard to see perhaps, but you've got this at home. So we've got this graph that looks like it's a fourth degree because it potentially could cross a horizontal line in 4 places. There's no guarantee it's a polynomial, but it says indicate absolute maximum minimum values. Well, between that as an endpoint and that as a starting point, this point here is the absolute maximum. So I'm just going to cheat and draw arrows to save time. That's the absolute maximum. The absolute minimum value is right down there. The lowest point it is anywhere over that interval from 0 to 20. The local maximum is right here. Okay? And also, that is a local maximum. The minimum value is only 1 right there. We do not need to give the coordinates, it says, so I'm just going to draw arrows to those points. And then the inflection points are where it changes from being concave down, which this is, probably till about there, and then it switches to being concave up, so that's an inflection point. And then it appears to be another one about right there, and this one looks like it's concave down throughout, so I'm only going to list these two as inflection points. Alright, so there you go. The next two, a rectangular plot of land to be bounded on one side by a straight river, so there's our river. Here's a rectangular plot of land. That's going to be X, that's going to be X, that will be Y. We know we have 800 meters of fencing, so 2 X's, this side and that side, plus Y equals 800. We also know that we're trying to get the largest area. Well, the area is length times width, so area is equal to X times Y. If I solve for Y, we'll say Y is equal to 800 minus 2X, so I can replace that Y with what it's equal to. 800 minus 2x, and then sure, I might as well multiply that in. I don't have to, but it makes it a little bit more straightforward. 800x minus 2x squared. Well, what I want to do then is take the derivative and set it equal to 0, because I'm trying to find the maximum area. So it's going to be a parabola. It's opening downwards because that's minus, so we've got some kind of a parabola that's going like this in our graph, and we're trying to find that maximum area. I could do a minus b over 2a, but it says use calculus, so I'm going to do that by taking the derivative. A prime then is equal to 800 minus 4x, and if I solve this and set it equal to 0, I will get 800 equals 4x. So I divide both sides by 4, and x is equal to 200. So what are the dimensions then? That's going to be x is equal to 200, and y then would be equal to 400, because I'd have 200 in both those places. Alright, on to L'Hopital's rule. We use that when we get 0 over 0 or infinity over infinity on a limit. So this is approaching 1. If I plug 1 in, I get 0, and I get 0. So this is a case where I want to use L'Hopital's rule. I take the derivative of the top, and I get 3x squared minus 3 over, then when I take the derivative of the bottom, minus 1. And as x approaches 1, I get 3 minus 3 is 0. I get 0 then. So that is, after taking the derivative and plugging in 1, I will get 0 as my limit. Here again, check to see if I need L'Hopital's rule. I plug in infinity here. It says as x approaches infinity, e to the infinity is infinity. X, as it gets closer and closer to infinity, squared is infinity. So this is the second case. I'm going to take the derivative of the top and the bottom, and I get e to the x over 2x, which as that goes to infinity, the lim as x goes to infinity is still going to be infinity over infinity, so I do it a second time. I still get e to the x, but now I get it over 2, and the limit as x goes to infinity here is going to go towards infinity. So that's the limit of this one. Finally, if I plug in 0 here, e to the negative 0 is the same as e to the 0, which is the same as 1, and 1 minus 1 is equal to 0. Here when I plug in 0, that's getting closer and closer to 1, so 0 over 1 has a limit of 0. I do not need L'Hopital's rule. Okay? Here it says you must state why you're using the rule, so I might write a sentence about, well, when I plug this in, I get 0 over 0. Just to write a brief sentence in the interest of time, I'm not going to do that here. I get infinity over infinity. So that's why I'm using L'Hopital's rule, but here I do not need to. All right? There's that page.